Okay, guys, so here's a guide video. This is a non-calculator, and basically you just need to know, you need to know your Susan's table facts. I'll actually write you some things that like you would need to know for this. But okay, so we got this graph here. The graph of the continuous function g, the derivative of the function f is shown above. The function g is piecewise linear for this interval, and it's equal to this graph on this interval. If f of 1, okay, so the first thing, guys, that you should do, if you're given a graph and the graph you're given is the derivative of something else, you should immediately write that down for yourself. Okay, so when we're talking about g, we mean f prime. And at some point in our work, we're going to have to make that clear to our reader, that we understand that g is f prime. Okay, so part A, if f of 1 is 3, what is the value of f of negative 5? All right, we don't know what f is, but we've got the graph of f prime. So f is the antiderivative of g, and there is an antiderivative with an integral formula that comes up all the time on these free response problems. So this you need to know by heart. The antiderivative with an integral formula says this. It says that if we want to know f of x, then we just need to know f at some value of a, and then we add on to it the integral from a to x, so these variables are the same. And then inside the integral, you do f prime of w dw. And usually, guys, I use w because it's so different from x. It's so unusual that I thought it would help people remember that the variable here must be different than this input variable. Usually the AP people, if this is t, they use x here. And then if this is x, they usually use t here. Okay, but when I used to try to do that, students would just get, I don't know, for some reason it wasn't clicking, and so I use w. But this, as long as this variable is different than this one, you're good. Okay, anyway, so we're gonna figure this out. Okay, so I need to know f of negative 5. So I'm gonna have f of negative 5 equals f of a. What is the a? What's a value of f that I know? It's that right there. So it'd be f of 1 plus the integral from 1 to negative 5. And then f prime is g. So this is going to be gw dw. F of 1 is 3 plus. Guys, what does the integral mean? It means the area under the curve. So we've got the graph of g right up here, and we need its area from 1 to negative 5. So we're going to start here at 1, and then there's negative 5. Okay, so we are interested in this area. All right, and you want to make triangles and rectangles. So that's already a triangle. If I go like this, then I've got a triangle and a rectangle. Now I'm going to find the areas. This one right here, 1/2 base times height, we end up getting 1. This one here, 1/2 base times height, we end up getting 1.5. Just regular base times height, and we get 9. I think. Yeah. Okay. Now, the important thing to remember, guys, is that you're integrating backwards. So if you were integrating forwards, these would be negative areas, and then this would be a positive area. But if you're going backwards, your areas are going to have the opposite sign. So since we're integrating backwards, on a backwards interval, this will be negative, positive, positive. All right, so it's 3 plus negative 1 plus 1.5 plus 9. All right, and then this ends up being, what is this? That's 2 plus 10.5, so 12.5, okay, is that. Okay, so that's the answer to part A. Now we're gonna do part B. Okay, and as I say in every guide video, you wanna do as much of this on your own as you can. So this would be a good time to pause and maybe try to do more by yourself. All right, so part B, we're gonna evaluate this. Okay, so the integral from 1 to 6. All right, the integral from 1 to 6, g of x dx. Okay, so what we want is this area. Okay, now triangles, okay, the only time that you can find like exact area using geometry is if the area under the curve forms like a shape that we know the area of, like a triangle, a rectangle, a trapezoid, if you remember that area, a circle, a half circle, a quarter circle. So I gotta split this up. So I'm gonna, if I drop a vertical line here, then I could just use base times height for that part of the area. This looks maybe like a triangle. It's not a triangle because that's curved. Again, not a triangle. So how would you find the area under the curve of this part here? You'd have to use the fundamental theorem of calculus. So I'm going to split this up. So it's going to be the integral from 1 to 6, from 1 to 3 g of x. We could just use geometry for that, plus the integral from 3 to 6. And now from 3 to 6, g of x is that. So 2x minus 4 squared dx. Okay. Now I'm going to use geometry for this one, base times height. This one here, I've got to do a u substitution. So I don't know, maybe I'll find this one first. Okay, so that's just base times height here, so that's just 4. All right, so this integral, that whole thing is 4. And now for this part, I've got to do a u substitution. So u is going to be x minus 4. So du is just 1 dx. So there's really nothing special. I'm putting u in for x minus 4, and then I can automatically replace dx with du. Oh, I got to do the endpoints also. Okay, so 3 goes in here. So right now this is an x. So u is going to be -1 if x is 3, and then 6 goes in here. So u will be 2. And then this is 2u squared du. 4 comes down, fundamental theorem of calculus. That's where you do the antiderivative. So this is going to be 2/3, and do as much as you can on your own, guys. Now, if you're using u substitution on an indefinite integral, that's one where you don't have numbers, so you're just getting a formula and not an actual number. Then you've got to plug the u back in. But with definite integrals like this, you don't have to plug this back in for u. In fact, if you did, that would mess everything up because we already turned these into u's. So you'd also have to turn these back into x's if you wanted to plug the x expression back. So that's a huge mess. All right, so 2 goes in here, and I get 16/3 minus -1 goes in here, and I get -2/3. So this is 4 plus, that's 18/3 equals 4 plus 6 equals 10. All right, so that's for part B. Now part C. Okay, for -5 to 6, -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? For f to be increasing, we would need f prime positive. And for f to be concave up, we would need f prime increasing. Susan's table, you just need to know it. Give a reason for your answer. So I'm going to look for where and f prime is g. F prime is g. So I got to look for where g is both positive, so above the x-axis, and increasing. All right. So above the x-axis and increasing, so I can just ignore all of that. This is where it's above the x-axis. And the increasing intervals, so here it's increasing, and then also there it's increasing. So from 0 to 1 and 4 to 6. All right, and we got to give a reason for our answer. So this is part C. From 0 to 1 union 4 to 6, because g of x, which is equal to f prime of x, is both positive and increasing on these intervals. Okay, this is where you connect for your reader that G is F prime. Okay, when you're doing an explanation like that, you got to be very explicit. Like we've done some work, like here, for example, that is implying that we know G is F prime, but if it's an explanation, you've got to be very, very clear. Don't leave anything up to doubt. Okay, so part D. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Okay, so a point of inflection on f, since we've got the graph of f prime, we got to ask, well, what does that mean about f prime? So f prime is going to have an extrema. But really, guys, I'm noticing in the AP explanations, and I've mentioned this before, it looks like they're saying f prime changes from decreasing to increasing or increasing to decreasing, okay? Because that would mean, because an inflection point is a change in concavity. So if f prime went from decreasing to increasing, that would mean f went from concave down to concave up. And here would imply f went from concave up to concave down. So the AP people are giving this explanation, so I'm actually going to put this in Susan's table for when you're reviewing. So, I mean, you can look for extrema, and extrema means that a graph changes from increasing to decreasing, or vice versa. So these points, like these corners here, those are not extrema. It's only right here. F prime, which is G, changes from going decreasing to increasing. So I'm going to use their explanation. So for part D, x equals 4 because G of x, which is equal to F prime of x, changes from decreasing to increasing. Okay, that's how they explained it. In the past, we have explained it because g equals f prime of x has a local extrema. I think they would take that. If you slip up and you say that, I'm pretty sure they'll take it because that's the explanation I learned at an AP training. But like I said, in every rubric I've looked at, they've used this explanation. So I think this would be a for sure full points right there. Okay, guys, we're getting closer. You're doing great. Keep it up.